Hi, let's get on with problem number 69 in our series on JEE Advanced Problem Solving Strategies. And this question says, a line divides an equilateral triangle ABC of side 1 unit into two parts with the same perimeter and different areas S1 and S2. S1 and S2 is in square units, obviously. Now, the question is saying if the maximum value of S1 by S2 is equal to m by n, then we have to find the modulus of m minus n. Okay. So we have a triangle ABC which is equilateral and its side length is 1, and a line that divides that triangle into two areas. So we can make a line any way we like. Let's say this length is x. So this side will be 1 minus x. If this portion is y, this much will be 1 minus y. And let's label it A, B, C. Let's call this D and E. So basically there was a triangle ABC which was equilateral and each side of the triangle was 1 unit. Sides are 1. And now you have two parts of that triangle divided by this line. And the two parts are triangle ADE and quadrilateral BDEC, right? And the question has said that the two parts have the same perimeter but different areas S1 and S2. So let's call this as S1 and this as S2. And let's call the triangle's area as S. So first of all, we have S is equal to root 3 by 4 into 1 square. So root 3 by 4. And we have an equation S1 plus S2 should be equal to root 3 by 4. That is the first result. Then we have to say that the perimeter of the two parts are same, right? So we can say perimeter of ADE will be x plus y plus the length of DE, and the perimeter of BDEC quadrilateral will be 1 minus x plus 1 minus y plus side BC, which is 1, plus side DE, right? So notice that the DE unknown side is getting cancelled here. And we are getting 2x plus 2y is equal to 3, which implies x plus y is equal to 3 by 2. So this is the second result that we get, which is coming from the fact that they have the same perimeter. Now the question is asking us for the maximum value of S1 by S2, which is supposed to be m by n, right? The maximum value of S1 by S2. So for that, you will have to figure out what is the area of S1, right? So if I think about it, area S1, if you say this angle is still 60 degree because it was equilateral triangle, so it will be half into xy into sine 60. Half xy into sine 60, that is area of triangle ADE. So that is clearly root 3 by 4 times xy, right? Okay. So if area of S1 is root 3 by 4 xy, and what we have is total area was root 3 by 4. So we can say that S1 by the total area is equal to root 3 by 4 xy divided by root 3 by 4. So what we get is S1 by S is equal to xy, right? That ratio of area of S1 to the area of the whole triangle is xy. So let's do it on the next screen. We have S1 by S is coming as XY, and Y can be written as 3 by 2 minus X, because we saw in point 2, we got X plus Y is 3 by 2, right? So this becomes S1 by S is becoming 3x by 2 minus X squared, right? Our job is to find the ratio of S1 by S2. So what I can do is think about it like this. S1 plus S2 is S. So S1 by S2 plus 1 is equal to S by S2. So S1 by S2 is equal to S by S2 minus 1. So it is S minus S2 by S2, right? Okay, that is obvious. So we don't need to write that. What I mean is, if I find the ratio of S2 by S, right? S2 by S is going to be S minus S1 by S. So it is going to be 1 minus S1 by S. So that is going to be 1 minus 3x by 2 plus x squared, right? So S2 by S is this, S1 by S is this thing, and I want to find the ratio of S1 by S2. So I'm going to do it like this, 3x by 2 minus x squared divided by 1 minus 3x by 2 plus x squared. And now S1 by S2 has come as a function of one variable, right? It is a simple function of one variable which we can do maxima minima on. What have I done here? I have used the ratio of the areas to convert it like this. And xy was coming as the ratio of S1 by S. I converted into a function of one variable. And S2 by S was 1 minus S1 by S. So that became this. And S1 by S2 is coming out to be this value. Now we just have to do maxima minima for this. Now, one way to do it is by calculus. You can try the calculus method. We can also do it in a slightly different way by thinking about this ratio, this value S2 by S, and this can be written as x squared minus 3x by 2 plus 9 by 16 minus 9 by 16 plus 1. So this is x minus 3 by 4 whole square plus 7 by 16. So I know that S2 by S is equal to this. So from here I can say that S2 by S is greater than equal to 7 by 16, right? And if S2 by S is greater than equal to this, then S1 by S will be less than equal to 9 by 16, right? So by completing the square, I have gotten this result. And if S2 by S is greater than 7 by 16, since the sum of these two ratios must always be 1, because S1 plus S2 is always S. So if this is greater than this, S1 by S is less than this, right? So when I take the ratio here, S1 by S divided by S2 by S will be less than equal to 9 by 16 divided by 7 by 16. This is the maximum possible value that you can get, because in the denominator you have chosen the minimum value of S2 by S, which is 7 by 16, and the numerator you have chosen the highest possible value of S1 by S, which is 9 by 16. So from here I am directly getting S1 by S2 to be 9 by 7, which is the correct answer, and you can also verify it using calculus. Now mod of m minus n, S1 by S2 ratio was supposed to be m minus m by n. So mod of m minus n is simply 2, and that will become our answer, because m is 9 and n is 7, right? So here what I have shown you is a way to do this maxima minima problem without calculus, or you can try the derivative method also, right? But remember how we understood the problem? There was a triangle, there was a random line that was cutting it into two parts. We said that it divided the side in the parts x and 1 minus x, y and 1 minus y, and the perimeters of these two were supposed to be equal. This triangle's perimeter and this perimeter was supposed to be equal. That gave us x plus y is 3 by 2. And we already knew the area of this S1 will be root 3 by 4 xy. we are using the formula half into BC sine A, which gives us the area of any triangle, right? And the total area we already know S is √3/4. After that, it was just taking the right ratios and trying to maximize this S1 by S2. So hopefully you've understood the problem. I'll see you in the next video. That's it for now.